Good morning, friends. Today we are going to see the next point from the topic superposition of waves, that is the end correction, and as well as the vibrations of air column in a pipe closed at one end. Friends, first we'll see what is meaning of end correction. In order to understand the end correction, I am going to draw the diagram here. So this is a pipe open at one end. So when this is a pipe which is open at one end, there is a formation of the node and antinode will take place. Friends, it is observed that when the pipe is open at one end and the modes of vibrations of air columns are created, at the time node is formed at the closed end while the antinode is formed at the open end. Node is a point having the minimum amplitude, antinode is a point having the maximum amplitude. But it was observed that when we are measuring the length, suppose this is a small L, will indicate the length between the node and antinode. But later on, it was found that antinode is not formed exactly at the open end, but it is formed slightly upward in the direction as that of the pipe open at one end. So the additional factor small e should be added. So this small e is nothing but the end correction. So capital L is equals to small l plus e. What is the capital L? Capital L we can call as a corrected length, small l measured length, and small e as the end correction. So what is the end correction? End correction is the additional factor which is added in the measured length. So the end correction of the formula E is equals to 0.3d, where d is the diameter of the tube. So we can write the formula as L is equals to capital L, which is corrected length, is equals to small l plus 0.3d. Friends, again I am going to repeat the concept of end correction. It is observed that when the antinode is created at a point or at a side for the pipe open at one end, it is observed that antinode is not formed exactly at the open end, but it is formed a slightly upward direction. So the additional factor small e should be added, and this e is known as the end correction. So this should be added in the measured length. So capital L is equal to small l plus e. So E is equal to 0.3d, where d is the diameter of the tube. So the corrected length will become L is equal to small l plus 0.3d. Now friends, there is another condition. If the pipe is open at both ends, so this is for the one end. For the pipe open at both ends, so this is the condition for pipe open at both ends. What will be the end correction? So this is the antinode, node, antinode, right? So you will observe that here also end correction will be occur, and here also the end correction will occur. Means the end correction will be created at the both the side, and this will be the measured length. So here we can write that capital L, that is a corrected length, is equal to small l, that is a measured length, plus twice e. So capital L is equal to small l plus 2 quantity of e, 0.3d. So capital L is equal to small l plus 0.6d, where d is the small d is the diameter of the resonance tube. This tube is known as the resonance tube. So the capital L is equal to small l plus 0.63. So friends, for the end correction there are the two things: pipe open at one end and pipe open at both ends. If the pipe is open at one end, then the formula is capital L is equal to small l plus e, where e is the end correction and the value is 0.3d. And for the pipe open at both ends, the formula is that capital L is equal to small l plus 2e, Again we can substitute the 0.3d, so we are getting capital L is equal to small l plus 0.6d. So this is the concept regarding with the end correction. Now friends, we are going to see the next part of this topic, that is the vibrations of air column in a pipe closed at one end. Friends, this equation is important for 3 marks. For 3 mark type of the question it is asked. Sometimes it may be also asked for the 4 marks. So this is a very important question. Friends, we are going to see this equation in the by considering the case 1, case 2 and case 3, so that it will be very easier for us to write the equation. So first I am starting with the case 1. In the case 1, first I am going to draw the diagram. This is a node and this is a antinode, and this is the length. Suppose I am considering that the capital L is equals to lambda by 4. Okay, so this is the length, capital L is equals to lambda by 4. Friends, here I am going to write only the mathematical part. Theoretical part you should write while making your notes. So here we are going to see the case 1, case 2 and case 3 different format we will study. So in case 1, we have to describe the diagram. In given diagram, it is observed that the pipe is open at one end. At that time, the formation of the node and antinode will take place. The length of vibrating air column is L is equals to lambda by 4. That is the explanation, and then we should write the equation. So as L is equals to lambda by 4, so lambda is equals to 4L. You can consider this as equation number 1. V is equals to N lambda. N is equals to V by lambda. This is equation number 2. From equation 1 and 2, if we compare this equation, we can write as a N is equals to V upon 4L, but capital N is equals to small l plus E, so we can write N is equals to V upon 4L plus E. So this is the equation regarding the frequency. Friends, I am going to repeat this part once again. Here, one node and one antinode is formed. So length of the vibrating air column is L is equals to lambda by 4. What is the value of lambda? Therefore, lambda is equals to 4L. V is equals to N lambda. So N is equals to V upon lambda. So N is equals to V upon 4L. What is capital L? Capital L is equals to small l plus E. So we can write this is the fundamental equation of the modes of vibration of vibrating air column. This is the fundamental equation. This is the fundamental equation, or we can write this is the fundamental frequency of mode of vibration of air column, or we can write this is the first harmonic. This is the equation for first harmonic. Fundamental frequency is equal to the first harmonic. The lowest frequency in the vibration of air column is known as fundamental frequency or first harmonic. So regarding this, in last grade we also studied what is the meaning of the harmonic and overtone. So here this is the first harmonic, means the lowest frequency. Friends, as now we are going to consider the case 1, case 2 and case 3. So I am going to write here N1. So N1 will indicate that this is the fundamental frequency of the modes of vibration of air column. So this is the case 1. So once you are clear with the case 1, then it will be very easy to write for the case 2 and the case 3. So case 2, the case 2. Here formation of node, antinode, node, antinode will take place. Friends, this is a complete loop. So the distance between the two nodes is a lambda by 2. This is a node and antinode. So this is a lambda by 4. This is a lambda by 2 plus lambda by 4. If we are adding, we are getting the 3 lambda by 4. So the length will be the 3 lambda by 4. Length here is equal to 3 lambda by 4. So once you have got the length, then you should describe the diagram. In given diagram, it is observed that the there is a formation of the two nodes and two antinodes will be get formed up. So the length of vibrating air column is L is equal to 3 lambda by 4. So we can begin with the equation with here L is equal to 3 lambda by 4. Lambda is equal to 4L upon 3. So we can consider this as the equation number 3. Now we have to write the equation for the velocity. V is equal to n2 into lambda. So n2 is equal to v upon lambda. So n2 is equal to v upon what is the of lambda? 4L upon 3. It will be goes to the numerator. So it will becomes n2 is equal to 3v upon 4L. Right, so 3v upon 4L. So we can write here n2 is equal to 3v 4 into bracket L plus E and v upon 4L plus E, that is nothing but L1. So we can write the L2 is equal to 3L1. So this is the equation for second harmonic or first overtone. The second harmonic is another first overtone. Friends, I am going to repeat this equation once again. Here, once we draw the diagram, then we have to describe the diagram. That in given diagram, the formation of two nodes and two antinodes will take place. The vibration, the length of vibrating air column is L is equal to 3 lambda by 4. Therefore, lambda is equal to 4L upon 3. V is equal to n2 into lambda. n2 is equal to v upon lambda. So we can write the equation number n2 is equal to v upon lambda as equation number 4. So from 3 and 4, from equation 3 and 4, we are getting n2 is equal to v upon 4L upon 3. 3 goes to the numerator. So n2 is equal to 3v upon 4L. So L is equal to small l plus e. So v upon 4L plus e, that is nothing but the L1. Which we have got here. So n2 is equal to 3L1. So this is the equation for second harmonic or first overtone. So this is the case 2. Now we'll see the case 3. So this is a diagram for the case 3. So this is a node, antinode, node, antinode, node, antinode. Friends, here the distance between the two nodes is lambda by 2. Distance between the again two nodes is lambda by 2. Lambda by 2 plus lambda by 2 lambda, and node and antinode lambda by 4. So lambda plus lambda by 4, that is nothing but the 5 lambda by 4. So we can write first here the length of vibrating air column is 5 lambda by 4. So here we have described the diagram. In given diagram, it is observed that 1, 2, 3, 3 nodes and 3 antinodes are created in the vibration of air column. Then we should begin the equation. The length of vibrating air column is given by the formula N is equal to 5 lambda by 4. So here we have write length L is equal to 5 lambda by 4. So lambda is equal to 4L upon 5. So this is equation number 5. Now V is equal to, now here we have written the N3 into lambda. So N3 is equals to V upon lambda. We can consider this as equation number 6. So from 5th and 6th we can write N3 is equals to V upon 4L upon 5. It will goes to the numerator. So N3 is equals to 5V upon 4L. N3 is equals to 5V upon 4L. And what is the value of L? So here we can write the value as N3 is equals to 5V. Now you can observe here L is nothing but a small l plus e. So 5V upon 4L plus e, and V upon 4L plus e is nothing but the N1. So we can write as N3 is equals to 5N1. N3 is equals to 5N1. So we can write this as the equation, and we can say this is the equation for fifth harmonic or second overtone. Friends, I am going to explain this part once again. So here length L is equals to 5 lambda by 4. So lambda is equals to 4L upon 5. V is equals to N3 into lambda. So N3 is equals to V upon lambda. So N3 is equals to V. What is the value of lambda? 4L upon 5. 5 goes to the numerator. 5V upon 4L. So N3 is equals to 5V upon 4 into bracket L plus E. So N3 is equals to 5N1. So this is the equation for fifth harmonic or second order. Friends, again I am going to explain these equations. Here case 1, case 2 and case 3 we have studied. In this case 1 we have got the equation as N1 is equals to V upon 4L plus E. So this is called as the fundamental frequency or first harmonic. Then in the case 2 we have got the equation as N2 is equals to 3N1. So we can call it as 3N1. So I can write here third harmonic. Sorry, here do the correction. This is the equation for the third harmonic or first overtone. The frequency greater than the fundamental frequency is known as the overtone. So this is the equation for the overtone. After this, in case 3, we have got the equation as the N3 is equals to 5N1. So this is the equation for the fifth harmonic or second overtone. If we observe here numbers, we are getting the number 1, 3 and 5. So we can write only the odd harmonics are present in case of pipe open at one end. So that is a conclusion from the above equation. What we can say, when the pipe is open at one end, then we are getting only odd harmonics. I am writing the conclusion. First is the only odd harmonics are present there. And if we want to write the condition for overtone, Np is equals to 2n plus 1. Np is equals to 2n plus 1 or 2p plus 1 into n, where p is equals to 1, 2, 3 and so on. So if I am substituting p is equals to 1, so what I am getting 3m. So when I am getting the 3m, so this is the condition for the first overtone. If I am substituting p is equals to 2, I am getting the 5m, and 5m is the condition for the second overtone. So this is the formula for the overtone. So what is the overall conclusion from the above equation? So friends, I have written in the mathematical format. You are writing the complete sentence that in case of the pipe open at one end, only odd harmonics are present. And second conclusion, the general condition for the formation of the overtone is Np is equals to 2p plus 1 into m, where p is equals to 1, 2, 3 and so on. So I hope you have understood this point. Friends, try to make the notes properly. Here only I have done the mathematical part. While making the notes, you should add the theoretical parts also. So thank you. Have a nice day.